Okay, hi, my name is Craig Daly. I'm a senior lecturer in the School of Life Sciences. So for around about 25 years I've been using confocal laser scanning microscopes to collect 3D data of microscope samples. I was given a demo of a VR headset, fully immersive headset, the HTC Vive, during the summer 2017, and I realised that I had data that was in a format that could quite quickly be processed into a VR environment. And so I've spent the last couple of months working out a workflow as to how I would take data from a microscope through several software packages and then into a fully immersive VR environment. At present, a lot of the VR headsets are used for gaming, and there's not really a lot of science there. And that's really what I'm aiming for with this project, is to take 3D scientific data and create animations and VR experiences with real 3D anatomical and perhaps molecular data or content. So to build our own in-house content rather than be dependent on buying content from third-party suppliers. Also, I think if we can alert the researchers within our school and our institutes and beyond, hopefully they will realise that a lot of their own 3D data that they're collecting on a regular basis could also be visualised in this way. The confocal microscope is a microscope which has multiple lasers and enables us to scan the preparation in 3D. So we get a 3D digital map of our structure, and in my case it would be the structure of a blood vessel. That data then has to be processed in such a way that I can extract the features that would be of interest, maybe the nerves, some cells that I'm interested in, bits of fat, could be anything. Once I've reduced the geometry or the mesh down to something that's usable in an animation package, I would then put it into software like Autodesk Maya or Autodesk 3ds Max, along with any lighting, textures and animations that we may choose to add. We can then export to Unity 3D. So I can plug my virtual reality headset into my computer, which is running Unity. I can load my now meshed confocal data and visualise it in a completely immersive environment. The students that I've spoken to have been really quite excited at the prospect of having content delivered in a VR environment. Now, whether or not VR is an effective teaching tool is something that I'm interested in from an educational point of view. How do we design an effective environment for students to learn in? With the opportunity for me to stand in my office in front of my data set, which is now projected in front of me at a size of about 1.5 meters square, where I can walk around it, I can walk through it, I can view it from any angle, I've found that really gives me a far better understanding of the interaction between these complex structures. And I really do believe that it will help students to understand more quickly how complex interactions and how complex structures can work together.